All right, so everyone's heard about all these AI tools, right? Like the ones that write poems and answer trivia questions. But what about AI that can actually do things in the real world?
That's
That's a big leap.
it is.
Moving from AI that can just process language to AI that can like actually take action.
Yeah, and that's exactly what this white paper we're looking at today is all about.
Okay.
It's called Agents by Weisinger, Marlowe, and Vuskovic. And it really gets into how we can...
So this paper is,
Yeah.
it's dense, but
Yeah.
it's packed with some really interesting ideas that are going to reshape how we think about AI. So we're going to try to unpack it all today. And we're going to start with the most basic question. What is an agent?
Well, the authors give a very specific definition. It's, quote, an application that attempts to achieve a goal by observing the world and acting upon it using the tools that it has at its disposal, unquote.
Okay, so we're not just talking about like a chatbot that can just spit out clever responses, right? We're talking about something that can actually make things happen
Exactly.
in the real world.
Yeah, precisely.
Yeah.
It's the difference between having a brilliant mind sort of stuck in a library
Right.
versus like a skilled craftsperson with a toolbox.
Yeah.
One has all this knowledge, the other can actually apply it to, create something new.
Okay, that clicks.
Yeah.
That makes sense. But how is this different from the large language models we keep hearing about? I mean, those are already pretty good at understanding like instructions and responding to them.
They're very powerful, but their knowledge is limited to the data they were trained on.
Hmm.
They can't go out and interact with the outside world to gather new information or execute tasks.
So it's the difference between like knowing all the theoretical steps to bake a cake,
Right.
but not actually having the tools and
Yeah.
ingredients to actually bake the cake.
A perfect analogy. The paper really highlights how, the magic of agents comes from this ability to connect to external systems like databases,
Yeah.
APIs, the whole digital world through what they call tools.
Okay, tools. Let's talk about tools. But first I want to understand, how are these agents structured?
Right.
The paper mentions three core components, right?
Yeah. There's the model, the tools, and the orchestration layer. You can think of it like a skilled chef.
Okay.
The model is like their knowledge of recipes and techniques.
Mm-hmm.
The tools are their kitchen equipment.
Right.
And the orchestration layer is their ability to sort of plan and adapt and execute,
Mm.
a delicious meal.
These food analogies, I love it.
Yeah.
So the model is like the brain of the agent.
Exactly. It's typically a large language model that can, reason and make decisions, understand complex instructions. But here's a fascinating insight from the paper. The model actually performs best when its training data is specifically tailored to the types of tools it'll be using.
Wait, so it's not enough to just have like a generally intelligent model. It needs like specialized training based on the tasks it's actually going to perform.
Think about it. A chef who's trained in like French cuisine might struggle if you suddenly asked them to, make sushi without any guidance or practice.
Oh, that's a great point.
Yeah,
It's like giving the model a head start by teaching it the language of the tools
Like
it's going to be using.
exactly.
Yeah.
Now let's move on to the tools themselves. The paper really emphasizes how these tools bridge the gap between the agent's internal capabilities and the external world, enabling it to take real-world actions.
So the model might know how to like book a flight in theory,
Right.
but it needs a tool that can actually interact with a flight booking API to make it happen.
Exactly. And the paper dives into three main types of tools. You have extensions, functions, and data stores. Each one kind of serves a different purpose in expanding the agent's capabilities.
Okay, let's unpack those, starting with extensions. What are those all about?
So extensions are essentially translators
Okay.
between the agent and external APIs. They take the agent's instructions and convert them into a format that the API can understand.
So it's like having a multilingual interpreter that can help the agent speak the language
Exactly.
of any API it needs to use.
That's a great way to put it. The paper gives the example of booking a flight from Austin to Zurich.
Hmm.
The agent wouldn't need to know the intricacies of the flight booking API. The extension would handle all those technical details, extracting the key information from the user's request and making the appropriate API calls.
So instead of hard coding every possible interaction, we have these like flexible extensions that allow the agent to dynamically adapt to different APIs.
Exactly. And to make things even easier for developers,
Yeah.
Google's actually offering pre-built extensions like the code interpreter,
Wow.
which can be used right out of the box.
That's amazing.
So you don't even need to be like a coding whiz to start building agents that can generate and run Python code.
Wow, so the barrier to entry for building powerful agents is getting lower and lower.
It is.
This is pretty mind-blowing.
Yeah.
But we still have two more tool types to explore: functions and data stores. What can you tell us about those?
All right, so functions in the context of agents are similar to functions in software engineering.
Okay.
They're self-contained blocks of code that perform specific tasks.
Right.
But here's the key difference. With agents, it's the model itself that decides which function to use and what arguments to pass in.
So instead of a programmer like dictating every step, the agent's model is making decisions about how to utilize these functions based on the task at hand.
Precisely. This gives developers a tremendous amount of flexibility and control. They can create a library of specialized functions, and the agent's model can dynamically choose the most appropriate one based on the situation.
That's a really clever approach. It's
Yeah.
like giving the agent a set of building blocks and letting it figure out the best way to assemble them.
Exactly. And the paper highlights some key advantages of using functions.
Okay.
For example, they can enhance security by allowing the API call to be handled on the client side,
Oh, interesting.
rather than by the agent itself. They can also offer timing advantages, making the agent's responses much faster.
So it's not just about like expanding the agent's capabilities.
Right.
It's also about making it more
Yeah.
secure
Yes,
and
sir.
efficient. Okay, data stores. How do those fit into all of this?
All right, so data stores address kind of a fundamental limitation of language models.
Okay.
Remember how we talked about models being like libraries
With a fixed set of books.
with a fixed set of books? Well, data stores are like constantly updating those libraries with new information.
So they allow the agent to access knowledge that goes beyond
Right.
its initial training data.
Right.
So it's constantly kept up to date with the changing world.
Exactly. This is crucial for real-world applications where information's always evolving. Data stores act like the agent's external memory, giving it access to a vast and dynamic knowledge base.
Okay, this is where it gets really exciting.
Yeah.
We now have these AI agents that can not only understand and process information, but can also take action in the real world, leverage specialized tools,
Right.
and even tap into external knowledge sources.
Yeah, and we've only just begun to explore the potential of these agents. The paper goes on to discuss how these different components come together in a process called targeted learning, which allows agents to really refine their skills and become even more effective at achieving their goals.
All right, targeted learning. That's where we'll pick things up in the next part of our deep dive.
That's right.
We'll explore the intricacies of targeted learning, and we'll see how it pushes the boundaries of what these AI agents can accomplish.
Right. Welcome back. So we've been laying the groundwork here, trying to understand these AI agents, exploring their core components and the tools that give them these real-world capabilities.
Right. We've talked about how these agents have like a brain, the model, a set of hands, the tools, and then like a control center, the orchestration layer.
Yeah. And before the break, you were particularly intrigued by that concept of data stores, which essentially give agents access to a constantly updated knowledge base.
Yeah, it's like having a research librarian on speed dial constantly feeding the agent the most up-to-date information.
That's a great way to visualize it. But now let's shift our focus to how these agents actually learn and improve their performance.
Okay.
The paper dives into this fascinating concept called targeted learning.
Targeted learning, it sounds like we're about to give our AI agents some specialized training.
Exactly. You see, even the most advanced language model has its limitations.
Okay.
General knowledge is a good foundation, but sometimes you need specialized expertise for specific tasks.
So it's like the difference between someone who knows the basic rules of chess
Right.
and then a grandmaster who can anticipate moves and strategize multiple steps ahead.
Precisely. Targeted learning is about giving agents the tools and techniques they need to become true experts in their respective domains.
Okay, I'm hooked. Tell me more. How does this targeted learning work? The paper mentions a few different approaches, right?
Yes. The authors outline three main approaches: in-context learning, retrieval-based in-context learning, and fine-tuning-based learning.
Whoa, hold on. That's a lot of learning. Can we break those down one by one, starting with in-context learning? What's the key idea there?
All right. Imagine you're trying to teach someone a new skill. Let's say how to bake a specific type of cake. With in-context learning, you wouldn't start from scratch with like all the basic principles of baking.
Right.
Instead, you'd give them the recipe, the key ingredients, and maybe a few examples of similar cakes they've tasted before.
So it's like giving the agent a set of instructions, the necessary tools, and a few hints based on past experience.
Exactly. The agent uses its general knowledge, the prompt, and those few-shot examples to figure out how to complete the task. It's a form of on-the-fly learning that allows agents to adapt to new situations quickly.
That's really clever. But what about retrieval-based in-context learning? How does that differ from the basic in-context approach?
Now imagine that instead of just a few examples, our baker has access to a massive library of recipes and culinary techniques.
Okay.
They can dynamically pull in relevant information and examples based on the specific cake they're trying to make.
So it's like expanding the agent's knowledge base on demand,
Right.
giving it access to a vast repository of information that it can use to improve its performance.
Precisely. Retrieval-based, in-context learning leverages those data stores we talked about earlier, allowing the agent to dynamically pull in relevant information from external sources. This gives it a much richer context for understanding the task at hand and coming up with creative solutions.
This is amazing. It's like giving the agent a superpower,
Yeah.
the ability to learn and adapt at an incredible pace.
Right.
Okay, but what about fine-tuning based learning? How does that fit into the picture?
Think of fine-tuning as sending our baker to culinary school.
Okay.
It involves training the model on a huge data set of specific examples before it's ever given a task. This helps it develop deep expertise in a particular area.
So it's like pre-programming the agent with a specialized skill set, making it highly proficient in a particular domain.
Exactly. This is particularly useful for tasks that require a high level of accuracy or very specific knowledge.
Okay, this targeted learning stuff is really blowing my mind. It's like we're giving these AI agents the ability to constantly learn and evolve,
Right.
becoming more and more capable over time.
And this is where things get really exciting.
Uh,
When we combine the core agent components,
yeah?
the model, the tools, and the orchestration layer with these targeted learning techniques, we start to unlock the true potential of AI agents.
It's starting to feel like we're building an AI master chef,
Yeah.
piece by piece, technique by technique. But the paper doesn't just talk about the theory, right? It also gives some practical examples of how to build these agents.
You're right. They introduce a popular open source library called LangChain,
Oh, okay.
which acts as a powerful framework for building and customizing agents.
LangChain, I remember you mentioned that name earlier. What makes it so special?
LangChain makes it incredibly easy to chain together different actions and tools,
Okay.
creating complex workflows for your agent. It's like having a set of Lego bricks that you can use to build any kind of agent you can imagine.
Okay, I'm officially geeking out over here. Can you give us a taste of how LangChain works in practice? The paper mentions a simple example using SERP-TI and the Google Places API.
Sure. Imagine you ask the agent a multi-part question like, who did the Texas Longhorns play in football last week? And what's the address of the other team's stadium?
Okay, a sports-themed challenge for our AI agent.
Right.
How does it handle that?
First, the agent would use SERP-TI, which is a tool for interacting with Google Search, to find the Longhorns' recent football schedule. Let's say it discovers they played the Georgia Bulldogs last week.
Got it. Step one complete. Now, how does it figure out the stadium address?
That's where the Google Places API comes in. The agent uses this tool to search for Georgia Bulldogs Stadium, retrieves the address, and then presents you with both answers in a clear and concise format.
So it's like the agent is following a trail of clues,
Right.
using different tools to gather information and solve different parts of the puzzle.
That's a great way to think about it, and this is just a simple example.
All right.
LangChain allows you to build much more complex agents that can handle a wide range of tasks, from booking appointments to conducting research to even generating creative content.
This is incredible. We've gone from theoretical concepts to practical tools that allow anyone with a bit of coding knowledge to build their own AI agents.
And it doesn't stop there.
Oh, no.
The paper takes us even further down the rabbit hole by introducing Google's Vertex AI platform, which offers a managed environment for building production-grade agents.
Vertex AI agents. That sounds serious. Tell me more about that.
Vertex AI is Google's cloud platform for machine learning and AI development. It provides a whole suite of tools and features specifically designed for building, testing, and deploying sophisticated agents that can handle real-world tasks.
So it's like taking those LangChain prototypes
Right.
and turning them into fully fledged applications that can be used in businesses and organizations.
Precisely. Vertex AI offers features like Vertex Agent Builder, Vertex Extensions, Vertex Function Calling, and even a Vertex Example Store for providing targeted learning examples. It's a comprehensive platform for taking AI agents from concept to reality.
Wow, this is getting more and more exciting. We're talking about a whole ecosystem for building and deploying powerful AI agents that can transform industries and solve real-world problems. But before we get too carried away with the possibilities, I have to ask, what about the potential downsides?
That's a crucial question, and it's one that we'll explore in the final part of our deep dive. We'll delve into the ethical considerations surrounding AI agents, the potential risks, and the challenges we still need to overcome.
Okay, listeners, you won't want to miss this. We're about to wrap up our deep dive into the world of agents with a thought-provoking discussion about the future of this technology and its impact on society. Welcome back to the deep dive. We've been on quite a journey exploring these AI agents from their core components to those tools that give them real-world power and those targeted learning strategies that help them level up their skills.
It's been fascinating to kind of unpack how these agents are pushing the boundaries of what AI can do,
Wow.
moving from passive language processing to active problem solving in the real world.
Exactly. And before the break, you hinted that we were going to get a little hands-on, see how these agents are actually built.
Right.
I'm ready to roll up my sleeves.
All right, let's do it. We won't be building a super complex agent from scratch, but we can definitely give you a taste of the process
Okay.
using some of the tools and techniques we've discussed.
Okay, I'm all for a taste test. What kind of agent are we going to whip up today?
Let's imagine you're fascinated by the history of coffee, and you want an AI agent that can answer your questions on that topic, pulling information directly from a website like Wikipedia.
I love it. It's like having a personalized coffee historian at my fingertips.
Exactly. So our data source is the Wikipedia page on coffee, and we'll use the LangChain library to build our agent. Remember, LangChain's like a Lego set for creating AI agents?
Right. It provides all the building blocks and lets us snap them together in different ways to create different functionalities. So how do we get started? Do we just copy and paste the whole Wikipedia page into LangChain?
Not quite. First, we need to extract the relevant text content from that Wikipedia page using a technique called web scraping.
Okay.
There are tools specifically designed for this.
So it's like we're sending a digital spider to crawl through the Wikipedia page and gather all the juicy text.
That's a great analogy. Once we have the text, we need to break it down into smaller, more manageable chunks
Okay.
that our agent can easily digest. LangChain has a handy feature called text splitters for this purpose.
So instead of feeding the agent a whole encyclopedia,
Right.
we're giving it bite-sized pieces of information that it can process more efficiently.
Exactly. Think of it like organizing a messy library into neatly labeled shelves. It makes finding the right information much faster and easier.
Okay, that makes sense. But where do we store these neatly organized chunks of text?
This is where those data stores come into play.
Oh, great.
Remember, data stores are like the agent's external memory. For this example, we'll use a type of data store called a vector database.
Vector database. Sounds pretty high-tech.
It is, but the concept is actually quite simple. A vector database converts each text chunk into a numerical representation called a vector.
Okay.
It can then quickly compare these vectors to find similar chunks of text.
Ah, so it's like using a super fast search engine
Right.
that can find the most relevant information based on the meaning of the text.
Precisely. So when you ask our coffee agent a question like, when was coffee first discovered? It converts your question into a vector, searches through the vector database, and finds the text chunk that most closely matches the meaning of your query.
Okay, I'm starting to see how all the pieces fit together.
Yeah.
But once the agent has found the relevant text chunk, how does it actually formulate an answer to my question?
That's where the language model comes in.
Okay.
We feed the relevant text chunk and the original question into the language model. The language model, with its vast knowledge of language and context, generates a clear and concise answer.
So it's like the language model is acting as a translator, taking the information from the text chunk and presenting it to me
Right.
in a way that's easy to understand.
That's a great way to put it.
Right.
There you have it, a simple AI agent that can answer your coffee-related questions, powered by web scraping, text splitting, a vector database, and a language model.
This is incredible. We've literally built a mini coffee historian. And I bet with a bit more tweaking and refining, we could create even more sophisticated agents that can answer all sorts of questions on a vast range of topics.
Absolutely. This is just a glimpse into the world of agent building. The tools and techniques are constantly evolving, opening up new possibilities for what we can create.
This has been an incredible deep dive.
It has.
We've gone from understanding the fundamental building blocks of agents to exploring real-world applications and even getting a taste of how to build our own.
Yeah. We've seen how agents are really blurring the lines between passive AI and active AI, enabling them to interact with the world in ways we never thought possible.
And I have to say, I'm walking away from this feeling both excited and a little bit intimidated by the sheer potential of this technology.
I think that's a healthy perspective. It's crucial to approach this technology with a sense of both wonder and caution.
Yeah.
AI agents have the power to revolutionize industries, solve complex problems, and even enhance our daily lives. But it's up to us to guide their development responsibly and ensure they're used for good.
Well said. So, to our listeners, we encourage you to keep exploring, keep learning, and keep asking questions. The future of AI is being shaped right now, and your curiosity and critical thinking are essential to navigate this uncharted territory.
And remember, this is just the beginning of the journey. Who knows what incredible AI-powered creations await us in the years to come?
Until next time, keep on diving deep